Hello viewers, welcome back to our YouTube channel. Did you know that force actually has a size, also known as magnitude, and a direction? The force used to pull an empty box is not the same as that used to push a table. One is relatively easier than the other. But in all cases, force acts in the direction of motion of the object. This means that when you push the object towards the north, it will move in that specific direction, meaning that force has both magnitude, also known as size, and direction. This unique feature is what makes force a vector quantity. A vector quantity is a quantity that has both magnitude and direction. How do we know the magnitude of a force? Well, it is measured using a spring balance. A spring balance is an instrument used to measure force. And the standard international unit of force is newtons, written as capital N, which is named after a great scientist, Isaac Newton. A spring balance has a hook where you attach object whose force you want to measure. It also has a scale which is divided into two sides. On the left side, there is G, and on the right side, there is capital N, which is our newtons. And for this case, we are going to focus on the right side, which has a scale running in newtons. For the sake of accuracy, let us check if this blue ring is lying exactly on the zero line. Yes, it is exactly on the zero line. That means that this scale is going to give us accurate results. From the 0 mark to the 0.25 mark, there are 5 small divisions. For us to be able to get the value, we need to get 0.25 divided by 5, which will give us 0.05. It means that each of these small divisions is 0.05 newtons. Now, we are going to measure the force exerted by each of these objects using our spring balance. We are now going to begin with this standard mass. We hang it on the hook, and now let's check where the blue ring is lying along this scale. If you observe closely, the blue ring is lying exactly at this black mark that is having 0.5. This means this mass is exerting a force of 0.5 newtons. Let's now measure the force exerted by the micrometer screw gauge. We hang our screw gauge on the hook. If you take a closer look, it is lying exactly on 0.75 newtons. This means that the screw gauge is exerting a force of 0.75 newtons. We can also measure the force exerted by this nail. After hanging it on the hook, we take a closer look and see where our blue ring is lying. The blue ring is lying just below the 0.25 mark. But remember, we say that each of these small divisions counts 0.05 newtons. It means when we get 0.25 plus 0.05, we shall get 0.3 newtons. So this nail has a force of 0.3 newtons. Just like that, you can measure the force of any object around you using the spring balance, but taking into consideration of its capacity, which is 2.5 newtons. The force required to move an object is influenced by how heavy or light the object is. For example, a child of about 200 newtons can pull an empty box, while an adult would require a force of about 500 newtons to push a table. Thank you for joining us today. Don't miss out on our next session as we uncover balanced and unbalanced forces. Don't forget to subscribe if you haven't. Please like and share. And if you have any question, drop it in the comment section. Bye-bye.